Good morning, everyone. Good morning. Hope all is well. All right, so we're waiting for a few people to get their audio connected, and we will go ahead and get rolling. All right, so once again, good morning. Hope all is well. Hope everything's going all right. Last class, we covered 2 sections, I believe. Let me check. Yeah, yep. And so we'll look at 1.4 and 1.5 today. We did 1.2, 1.3 last class, and we'll do 1.4, 1.5 today. So it won't let you join the audio, so I can't hear anything. Anybody else can hear me? Anybody?
I can hear you.
Okay, cool. All right, thanks. All right, so somebody's telling me they can't hear me, so I was just making sure it wasn't me. All right, hold on one thing.
So you said we're doing 1.4 and 1.5 today?
Yes, sir.
All right.
All right, and I haven't forgot you either, sir. I just gotta put that thing together for you.
Oh, you fine, man. You fine. I've been trying to navigate my way through a little bit further than where we are just to see what I don't know. Ooh, I got some questions for you.
All right, sounds good. So 1.4 is operations on real numbers and evaluating square roots. And I thought about it. Some of the things that I was going to send you, we may even cover. So we'll see. We'll work it out though. But Yeah. So the first thing we're talking about multiplying real numbers. So I'm going to give you the basic process when it comes to multiplying real numbers. Multiplying and dividing are very similar. So if I multiply 2 numbers that have the same signs, the result is going to be positive. If they're different signs, the result will be negative. So positive times positive is positive, negative times negative is positive. So we're over here. And then positive times negative is going to be negative, negative times positive will also be negative. So 2 numbers that have the same sign, when you multiply them together, will give you a positive result. 2 numbers that have different signs, when you multiply them together, will give you a negative result. All right. So over here on the right in the purple, I'll just give you simple examples of that. Positive 2 times positive 3 will be a positive 6. Negative 2 times negative 3 is also positive 6. Positive 2 times negative 3 is negative 6. Negative 2 times positive 3, negative 6. I'm going to convert after today. I will convert both lectures to YouTube, and then I'll send the links to you guys. All right, any questions? Can I scroll up? All right, so dividing is the same thing. Same signs give you a positive result. Different signs will give you a negative result. So positive divided by positive is positive. Negative divided by negative is positive. Positive divided by negative is negative. Negative divided by positive is also negative. So we see over here, positive 18 divided by positive 2 is a positive 9. Negative 18 divided by negative 2 is also positive 9. 18 divided by -2 is -9. -18 divided by +2, once again, is -9. All right. Any questions? Any questions? So I was trying to message one of the people. Okay, got it. All right. Can I scroll up? Pretty good. So I'll just give you the rules for multiplication, rules for division, give you rules for adding and subtracting, and then we'll just do some extra ones just to reinforce those rules. Okay, so let's look at adding. So when it comes to adding, I always say, think about your money. So if they're the same signs, you're gonna add the numbers that you have and keep the sign. If they're different signs, you excuse me, you're gonna subtract and then keep the sign of the greater. All right, so these first two right here, signs are the same. So we add them together and then we keep the sign. So in other words, if I have $5 in my account, I add $2 to it, that'll be $7. But if I'm negative $5 in my account and I get charged $2 again as a negative charge, I'm not gonna go positive, I'll go further negative in debt or further in debt. So -5 plus -2 would be -7. You add them together and keep the sign. And then here, your signs are different. You keep the sign, you subtract them and keep the sign of the greater. So if you have +5, you have $5 in your account, you pay $2 for some fries, you have $3 left. So let's say if you -$5 in your account, you're trying to get out of the red. So you add $2 to it, but you still have $3 in the red. So you subtract those two numbers, but keep the sign of the greater. Any questions? Any questions? Make sure we're okay. All right. All right, so looking at subtraction. So when it comes to subtraction, I always say convert it to addition and then just use your addition rules. All right, so if I look at 4 minus 3, and this is part of the transitional process or thought process when it comes to going into algebra, move from arithmetic to algebra, recognizing that this minus sign right here cannot be detached from that 3. What I have is a +4 and a -3 here. And it's not just 4 minus 3, because what that will do, allow you to move terms around and still keep the equivalency of your original problem, recognizing that you have a +4 and a -3 right here. So that's actually 4 plus -3, in which that's still 1. 4 minus 3 is 1, but 4 plus -3 is also 1. So how does that matter? It helps us when we're looking at a situation like this, and we have -4 minus 3, and we're so used to saying take away 3, and what people may make the mistake of is having a result of -1. -4 minus 3 is -1, but in actuality, that's not the case. We have a -4 and a -3. So -4 plus -3 is actually -7. So that's why I say, even if you don't write it out in your mind, you should be looking at adding these two negative numbers together. And then that will make us go back to what we did with addition. All right, so it really matters though when we look at these next two. We have 4 minus -3. But whenever you have a negative to a negative, that's going to be positive. So you don't really have a choice but to convert that to positive. 4 plus 3 is 7. And then in the next one, once again, negative to a negative turns positive. So -4 plus 3 will give you your -1. All right. So like I said, we're looking at addition. Looking at subtraction. It's easiest to convert it to addition and then use your addition rules. All right. Any problems before we do a few examples? All right, so I already got the answers written in here, but guess I'll just leave them and we'll just talk through them. All right, so the first one, -3 plus -11. So once again, we have a scenario here where we're adding two numbers that have the same sign. So doing so, we would just go ahead and add those numbers and keep the sign. So the result would be -14. All right. All right, the next one is just -1/4 plus 1/2. Now, I believe we mentioned before last class, whenever you're adding fractions or subtracting fractions, you do need a common denominator. And our common denominator is, or at least common denominator is 4. So that's the smallest number that both 4 and 2 can divide into evenly. All right. So we already have 4 as our denominator here. Then you say what times 2 will give us 4? And that will be 2. And whatever you do to the bottom, you have to do to the top. So that's why I multiply both top and bottom by 2. So now I have this situation, -1/4 plus 2/4. So now that I have 4 in the denominator of both fractions, I can go ahead and add my numerators, and that'll give me 1/4. -1 plus a +2. All right, any problems with that second one?
So can there be a situation where the whole fraction is negative? Like that -1 over 4? Is there a situation or a scenario where both of those numbers would be negative? And how could we read that?
Okay, so now when you say the whole fraction, I just want to, just make sure we parse, the terminology. So when you say the whole fraction, this is considered the whole fraction being negative. So now I know what you're saying though, so I'm gonna get to the part that you're saying. And so there's different ways of writing this. That's one way, -1/4. Another way of writing is having the negative sitting out front like that. And then another way of writing is having the negative down here. Now, this one it normally is not used as your final answer. That's just notation, having a negative down bottom, but either one of those 3 ways represent the same thing. Okay, so.
So how come you don't use a negative on the bottom?
Notation, just notation.
Okay.
And so, like I said, all 3 of these represent the same thing. You have -1 divided by 4, is going to be negative 0.25. 1 divided by -4 is still going to be negative 0.25. It's still going to be the same thing.
Okay.
It's just notation wise, they don't use this one as a final answer. They will use one of these two, either
Okay.
be up top or out front. Now, you also mentioned if you have the negative here and here. Well, if you have that, then the most simplest way of writing that is just to add 1/4. Because remember we said if you're divided by two negatives is positive.
Yes.
So the way you can reduce that is just by recognizing that negative over negative is positive. So it would just be positive 1/4.
Okay. All right. Thank you.
Mhm. All right, so the next one, -10 plus 15, different signs. So you're going to subtract them, but then keep the sign of the greater. The 15 was positive, so that's why we have a +5 right here. All right, the next one, -8 minus -1. So we have negative to a negative, that's going to turn positive. So we have -8 plus 1, and that'll be a -7. Different signs, subtract, keep the greater of the signs. So that's why it's a -7. Two minus 7, same thing as 2 plus -7. Once again, different signs. So we subtract them, keep the sign of the greater. So my result will be -5. All right, any problems? Okay, so here we have 11 plus 2 minus 7. So you can just do those from left to right. Add the 11 and the 2 first, and that gives us 13. And then 13 minus 7 is 6. All right, -8 times -7, positive 56. You know, negative times negative is positive. All right, original problem here. 7 times 1 times -2 times -3, and you just take your time, go from left to right. So the first thing, 7 times 1 is 7. Oh, I think what I did here was just showing you how you can multiply. Since it's all multiplication, you can all multiply in any order. So then I went ahead and multiplied -2 times -3, which gave me a +6. And that gave me 42. But if you wanted to, you could have did 7 times -2, which is -14. Then -14 times -3 will still give you a +42. So -14 times -3. But since it's all multiplication, you can do it in any order. Either way, you still should get +42. All right, so the next one is one that I normally get people with because people get so much in their flow. Notice the answer is 0. Well, the reason being is because anything times 0 is 0, and all of this is being multiplied by 0. So you really don't have to do 8 times 2 times 11, then times 0. You can just recognize that all of this is multiplication, and everything is going to be multiplied by that 0. So the answer, excuse me, the answer is just 0. So before we go to division, any questions? Any questions? All right, so -9 divided by -3 is going to be a +3. Then +20 divided by -4 is -5. All right. So now here, this next one we have -1/10 divided by -2/5. Whenever you're divided by a fraction, you're going to multiply by the reciprocal. That just means flipping the fraction. So that's what we did here. So we changed division to multiplication, and then we flip this fraction. So whenever you're dividing by a fraction, you are multiplying by the reciprocal. And the reciprocal, once again, is just flipping that fraction. After you do that, you can multiply across. -1 times -5 is +5. Oh, still have my eraser on. +5, and then 10 times 2 is 20. Then to finish the problem off, you do want to make sure that the fraction can or cannot be reduced. In this case, it can, because when you break down 20, 20 is 4 times 5, and then we also have 5 in our numerator. So it means 5 can cancel out with the numerator and denominator, and that leaves you with 1/4. So don't forget, if the whole thing canceled, then soon we know a 1 would be left. So that's 1/4 as our most simplified fraction. All right, everybody okay? And the last one, but I end up being 2, because whenever you have 0 in your denominator, it is undefined. You cannot divide 0 or divide by 0. So once again, if 0 is in your denominator, your answer is undefined. Now 0 in your numerator is okay. Your result will be 0. That's an actual number, but 0 in your denominator is undefined. And that will always be the case. So don't forget it, because no matter what math class you go into, what math class you will go into, 0 in your denominator will show up in some fashion. And it's something that you have to be careful of and watch out for. So do not want 0 in your denominator. Except stats. They don't pop up in stats, but calculus, pre-calc, trig, algebra. 0 in your denominator will pop up, and you have to address it. So any questions on anything before we go into square roots? All right. So when we look at square roots, this is our radical. Our square root symbol will be our radical. What's under the radical is considered or called our radicand. So when you look at a square root, you ask yourself what number times itself twice will give us the number under the radical, or in other words, will give us the radicand. So when I look at the square root of 9, if I want to take the square root of 9, the square root of 9 would be 3, because 3 times 3 gives me 9. So what number times itself twice will give me what's under the radical? Will give me that radicand. So the square root of 144 would be 12, because 12 times 12 is 144. Square root of 121 would be 11. Square root of 49 would be 7. Write that better. And so the next one, square root of negative 36. Notice the result or the answer that you will write is not a real number, because there's no such thing as two numbers that are the same number that you will multiply to itself that will give you a negative number. Because remember, negative times negative is actually positive. So you cannot multiply a number to itself twice to give you a negative number. So that would actually, the square root of a negative would actually take you into what we call imaginary numbers, which is not anything that we're dealing with. So all you would do is write not a real number. So if you ever taken the square root of a negative value for this class, you will write not a real number. All right. So the next one, we have the square root of 1/4. So you can take the square root of each, the numerator and denominator evenly. Square root of 1 is 1, because 1 times 1 is 1. Then the square root of 4 will be 2. All right. So in this last one, just wanted to emphasize the positioning of your negative sign. Notice this one right here, the negative is under the radical. This one right here, the negative is on the outside of the radical. So the negative is not affected by the radical. So you can take the square root of 36, which is 6. 6 times 6 will give you 36. But that negative is still on the outside, never affected by the radical. So your result or your answer here would be -6, because the negative is just sitting on the outside. Apply the square root to the 36, and you'll have -6. All right, any questions? Make sure we're okay. All right, so that's it for 1.4. Any questions before we look at 1.5? All right, so properties are real numbers. So look at a few properties, and then that'll be it. So the commutative property, we have the addition and multiplication representations of the commutative property. That's because any subtraction can be rewritten as addition, as we already talked about, but also any multiplication or any division can be rewritten as multiplication. All right, so just saying that, you can switch the order, but when it comes to addition and multiplication, and you will still get the same result. So that's commutative property. You can flip them around, still get the same result. So 4 plus 5 is 9. 5 plus 4 is also 9. And then 8 times 3 and 3 times 8 will still give you 24. So no matter which way you get it, if you're multiplying the same two numbers or adding the same two numbers, you still get the same result. All right. Associative property. So basically saying that if you have more than two numbers, it doesn't matter which one you associate with first or which ones you associate with first, you still get the same result. So if I have three numbers, if I decide to add A and B first and then C, I'll still get the same result as if I decide to add B and C first and then A. And the same thing with multiplication. So if I have 1 plus 2 plus 3, if I do 1 plus 2 first, that's 3. 3 plus 3 is 6. But if I decide to do 2 plus 3 first, that's 5. 1 plus 5 will still give me 6. So that's the associative property, just saying that whether it's multiplication or division, doesn't matter what order you do them in or apply the operation in, still get the same result. Excuse me. All right. Distributive property. It's saying that you have a number or term sitting outside of a parentheses, that term or number needs to be distributed into each term and multiplied to each term in the parentheses. So if I have an A times the quantity of B plus C, it will be AB, or A times B plus A times C. The same thing goes for if it's subtraction. You still distribute the same way. So if I have 3 times the quantity of X plus 2Y minus 5Z, that's a Z in the back, not another 2. So that'll be 3X plus 6Y, because 3 times 2. And then 3 times that negative 5 be negative 15Z. And then for the next one, if you have just a minus sign sitting out in front of the parentheses, you are expected to distribute that as well. So negative times that 4A would be negative 4A. Negative times negative 9B would be a positive 9B. Negative times 12 would be a negative 12. So every sign that's in the parentheses has to be changed because you're distributing a negative sign.
Can you say that again, please?
Every sign is going to be changed. So this negative sign has to affect each one of those. So notice how at first it was a positive 4A inside the parentheses, but now it's negative. And this one is positive and this one is now negative. So that negative sign on the outside of the parentheses did that.
Okay,
Oh.
thank you.
Okay, I was about to say, hopefully that made it a little better.
Yeah, yeah.
All right. So looking at another one, dealing with distribution. Oh, still have my eraser on. All right. So we have 1/2 times the quantity of 6x plus 14 plus 10. So notice we're going to distribute 1/2, but that 1/2 is not going to touch the 10. It's not a part of your parentheses or not inside of your parentheses. So we'll go ahead and distribute 1/2. Over here, I was just, I keep leaving that eraser on. So over here, I was just emphasizing that multiplication of the 1/2 process. You know, we have a 6 and you multiply it times 1/2. So that means you're going to divide it by 2. And so that's what we did to each one of these terms here. 6x times 1/2, 14 times 1/2. All right, 6 divided by 2, that'll be 3x. 14 divided by 2 is 7. And then you go ahead and add these two numbers in the back, your like terms. 7 plus 10 is 17. So now we cannot add these two together. One has an x in it, the other one doesn't. So that would be your most simplified way of expressing that expression. All right. Questions? Any questions? All right. So we have a few identities here. The addition. Identity, just basically anything plus 0 is going to be itself. Multiplication, anything times 1 will be itself. Those are your identity properties for addition and multiplication. All right. Inverse property. A plus negative A is 0. A plus 1 over A is 1.
When we get our book, will this sort of thing be in the textbook, or should we refer to the textbook tab in the Pearson lab?
It should be, are you talking about the hard copy of the textbook?
The hard copy.
Yeah, it should be in that as well. Because really the e-text that's in Pearson is just a copy of what you get in the hard copy.
Oh, so they're the same. Okay.
Yep. So that's why I had mentioned that you don't necessarily have to purchase the hard copy unless some people just like to have it in front of them. I'll be honest, I like to have stuff just right in front of me
Yeah.
versus going through the e-text. But some people are comfortable doing just e-text. So, but it's the exact same thing.
Oh no.
Almost did. Hold on, you broke up. Was that just me? I know you broke up on that last statement. Didn't quite hear you.
Oh no, I think that was me. No, just I need the hard copy. So I'm good with the book. I ordered book.
Oh man, I couldn't quite hear you. I might have to get that. I might have to get you to chat. Put that in the chat. I couldn't quite hear you. I don't know if it's me or you, but it's all good. Let's see. Any questions on anything that I said? And please, if ever I'm up here and technology is not giving you a good feedback, let me know so that if there's ever anything I need to repeat, or if need to type something in. Oh, okay, that was you. Okay. I got you. But trust me, like I said, I understand that I would rather have a hard copy in front of me as well. All right, so guys, that's it for chapter 1, actually. So there are only 4 sections in chapter 1. Let's go to let me share this screen with you guys. Yeah. So we have 4 sections in chapter 1, 1, 2, 1, 3, 1, 4, 1, 5. And then we'll get to chapter 2. And that's where our first test, when we close out chapter 2, that's when we'll be ready for our first test. Now, your first test will be something that you can do on your own, not proctored. So you don't have to worry about, what class period we'll be doing that timed or anything like that. So that will be on your own. Now, don't forget, though, you do need to send me a copy of your scratch work when you actually do this test and everything. And but yeah, as soon as you get there and ready to knock it out, you will be able to do so. Notice you have your test review right here. You don't have to do it. Remember, it's not mandatory, but I would suggest that you at least go in there and take a look at it to see what's going to be on your test so you can streamline your studies. And yeah. Any questions or concerns before we close out? Let's see something real quick. I was supposed to be going in this one. I think Yeah, okay. 2, 3, 4, 5, right. 4 distributive property. Yep, yep, yep. And so I forgot the book you guys have is chapter 2. Remember we switched to a new edition. So it's chapter 2 and then chapter 3. The old one, the old shell that I had, remember it was an old shell and everything. That was chapter 1, chapter 2, but your stuff is chapter 2, chapter 3. So sorry about that. Okay, no, that was okay. At this point, where should we be regarding the homework? So, excuse me. So you guys should be at 2.5. We covered 2.5 up to 2.5 today. So like I said, I forgot that we switched to edition and we're not in chapter 1. You guys start in chapter 2. Same content, same titles and everything, just that yours is 2.2, 2.3, 2.4, 2.5. And then when we come back, next class, I'll open the floor for questions, see if anybody have anything. If not, then we'll go ahead and roll it and start into chapter 3. And I'll go from there. So we have 4 sections in chapter 3, and then you'll have a test review and test. All right. Anything else? Any other questions before we close out? All right. So those 4 sections, check them out. Now remember also, you don't necessarily have to have everything completed, all 4 sections completed before next class. You know, as we progress throughout the course and as we get closer to closing out test 1's content, you know, so basically when we look at getting closer to closing out chapter 3, then we'll put a due date out there for when chapter 2 and chapter 3's content will be due. All right. Oh, so I just answered that. Yep. So no, you don't have to have everything done. Now, if you want to stay caught up with the lecture, then that's what you would do. But you don't necessarily have to. You know, you just, like I said, at some point we'll put a due date out there, and the due dates are normally on a Sunday, in which 2 and 3, which will be your first test, that content, that amount, that content will be due on that due date. All right. Anything else, anybody else before we close? All right. So you guys, somebody unmute?
Yeah, it was me. I'm gonna have questions, but I don't want to hold everybody else up because this ain't, you know what I mean, the questions ain't for everybody else.
Okay, not a problem, not a problem. So if you are done, if you don't want to sit back and see what his questions are, then the lecture is over for today. I will see you next class. Have a great weekend, be safe, and take care. All right, sir, what you got?
All right, so got a few things. So when I was doing homework, got some notes for you on my homework. So like some of the terminology has got me all types of twisted. Like I'm supposed to know a lot of these things that I don't know.
Mm-hmm.
And then one of the answers on one of the homework questions was 12 over 11.
Mm-hmm.
And that was like, how is that simplified? I thought simplified was supposed to be returning into into mixed numbers.
Nope. Simplified means if I have 4 over 6, then I can reduce that because 4 is 2 times 2. 6 is 2 times 3. The 2's can cancel, and the most simplified way of expressing that fraction is 2 over 3. So now, if I have 12 over 11, I do not have to convert it to a decimal. Neither do I have to convert it to a mixed number, unless the directions say so. So I do not have to do that.
Okay. All right. And then and some of those problems, like I don't know, I forget how far I went. Like I might be like in 2.4 or 2.5, but they had like graphing. It was a graphing question in one of those.
Okay. So
and
now
I don't know anything about that. Are we there yet? Are you going to teach us that before we get there, or am I expected to know?
Now, are you saying now if you're talking about, I'm looking at.
No, I plotted a number on a line, and that was fine. Like it told me to plot it on like X on the on the 5, and I put it where it was supposed to. But then the next question came up, and there was a whole chart, and it had tools on the answer selections that I had never seen before.
So now, do you know what problem number there was?
Oh no, I don't know what problem.
Because I don't. It's other than graphing on the generic number line like this, it shouldn't be asking you to do anything else. So that's why I'm trying to figure out what problem is asking you of that. Looking at. Because I know looking at chapter 4, that might pull on you to do something. Yeah, in chapter 4. But outside of that, it should just be a generic number line. So that's why, I'm trying to see what.
I'm trying to find it right now, but I can't.
Okay.
I can't even. I don't even know where to because I'm not really computer quick.
Mm-hmm.
Everything is a challenge to me.
Okay.
Just trying to navigate this and
All right.
that.
So let me ask you this. So it was more than just graphing on this line right here.
Let me get back on this screen on graph. Yes, it was more than that.
Okay. So yeah, I'll go looking for it as well. Go through your homework and see if you can find that problem. If you could email me that number so I can see what it's asking.
It's not the homework that's like I've gone ahead, right? So I've gone ahead. I've done maybe 3 or 4 different assignments.
Okay.
In a row. I'm just trying to gauge myself and figure out what I don't know. So a lot of the stuff I know, and I'm going through and I'm doing the problems that I have real problems with, I actually get the computer to do it out with me, and then I do a different problem and all that stuff. Like I've got, but for the most part, I got it. The biggest thing for me is not knowing the terms, what they mean when they say evaluate, because they say solve this problem in so many different ways. Like, and sometimes they don't tell me to solve the problem. It tells me something else. So like not understanding what I'm reading to be able to do what they want me to do per se has caused me to get a lot of wrong answers, and I've had to go back, and I figured out why, because it step by step tells you why. So I do appreciate that factor of the assignments 100%. But I want to know what I don't know.
Okay, so this is what I'm gonna need you to do. If you have now, if you have that information with you right now, then we can, it'll most definitely be helpful. What I need you to do is when you go through your homework, write down the number and what section, like the section, let's say 2.1, number 5. What does it mean to evaluate? You see what I'm saying? So that we can streamline exactly what terms we need to talk about at what type of problem and all the stuff like that. So that way I can even reference, I can just pull up MATLAB and go to that problem, and we can just address each one of them, according to what words are giving you problem, or just the process itself. And that will help us streamline our discussion and make proper use of what we're trying to do.
Yep, I will definitely do that, man. I'm going to go through, and the next class that we have, I'm not going to waste any more of your time today. And the next class that we have, I will have some more orderly questions for you.
Yeah, for sure. And then, like I said, that'll just help us streamline our time, and then we can just go right at it versus trying to find the problems. You know what I'm saying? That you had questions on, and most definitely look for that graphing one, because if it's not, now if it's in chapter 2, then we got a problem. But if it's ahead, then it's just something that we're going to talk about when we get there. You see what I mean?
Okay. All right, cool. All right. I appreciate your time. Thank you very much, man. You're awesome, dude. I appreciate you.
Oh man, appreciate you, bro. You have a good one.
Sir. I don't know how to correctly ask questions while you're lecturing, so I don't want to seem rude when I do. Is there a way that you prefer? Would you prefer me to say, "Excuse me, professor," or would you prefer me to just come out with the question?
Oh man, I'm easy like Sunday morning, man. I don't take none of that to heart, man. Just just unmute, say, hey, sir, whatever, excuse me, professor, it's fine, man. It's not a big deal, man. Uh,
Understood.
uh, I mean, I feel like I got a good beat on you, man. I don't think you're trying to do me no harm, no disrespect. So,
Not at all. Not at all. Not at
right,
all.
right,
I'm trying to use you for what for what you're there for.
right.
Exactly, man. So yes, I definitely appreciate you, man. Enjoy the rest of your day. I'll see you next class, brother.
All right, thanks. You take care.
Yes, sir.
All right, anybody else? Everybody good? All right, have a good one.